In this video, we're going to review how to draw Bohr-Rutherford diagrams for atoms. So a Bohr-Rutherford diagram is essentially just a model of an atom. It's a simplified way of representing what atoms look like. This is not the most accurate model. It's not the most modern model of the atom, but it's good enough to represent what we need in order to understand how reactions happen. So once again, a quick review. Remember that the atom in this model, or the atom, its subatomic particles are found in a nucleus. You have the protons that have a positive charge, the neutrons with no charge, and the electrons are not in the nucleus. They're in shells or energy levels, and they have a negative charge. So once you understand the concept of what the model of the atom should look like, then it's easy to draw it. So again, you can see here we have the protons in the nucleus. This is the nucleus over here. 6 protons, 6 neutrons. And then after that, we have the electrons in the orbits. And this is a Bohr-Rutherford diagram for carbon. Bohr-Rutherford named after scientists that contributed to the model of the atom. A couple things you need to remember as well. So again, these are called shells, where you see the electrons. Those are called shells. They can also be called energy levels. And you'll notice that this particular atom has 2 shells, one here and one here. So this is shell 1, shell 2. This first circle is not a shell, it's the nucleus. And another important point to realize is that the last shell for any atom, the last shell, is called the valence shell. And any electron on that valence shell is called a valence electron. And the reason we point that out is because valence electrons are the ones that participate in chemical bonds when compounds form. So this carbon atom has 6 electrons total, 2 on the first and 4 on the last. But if I were to ask you how many valence electrons it has 1, 2, 3, 4 valence electrons. There's another diagram you may have learned how to draw called a Lewis dot diagram. It's a little bit simpler to draw. It actually only represents the valence electrons, and we'll see that in more detail later on. But if I were to draw that, I'd simply put the element symbol, then go 1, 2, 3, 4. That represents 4 valence electrons. So everything else, all the other protons, neutrons, and other electrons, the inner electrons or core electrons, are replaced by a symbol, and then the valence electrons are represented. But for this lesson, we're going to focus on the Bohr-Rutherford diagram. I will add the Lewis dot diagram in the examples just to get you started thinking about how to draw those. Lewis dot diagrams only represent the valence electrons, because remember that they're the ones that are participating in the bond. So what's the point of drawing every single one of them if we know it's the valence electrons that are the most important ones? So when you're drawing a Bohr-Rutherford diagram, you're representing all the electrons that that element has. So a Bohr-Rutherford diagram is a simplified model of an atom. It represents all the electrons, all the protons, all the neutrons. The general rule of thumb in grade 11 and grade 10 as well, in grade 9, is that the first shell will carry up to a maximum of 2, second a maximum of 8, and third a maximum of 8. So max of 2, max of 8, max of 8. So essentially you're just filling out the shells. As one fills up, you go to the next one. When the next one fills up, you go to the next one. And in grade 12, you learn about what happens beyond that. And you'll learn actually that the third shell in grade 12 actually can hold more than 8 electrons. But to keep it simple, we're going to stick with the 2-8-8 rule for now. So when you're trying to draw a Bohr-Rutherford diagram, this is the list of steps that I recommend doing. First, I'd recommend that you find the number of protons, electrons, and neutrons as an exercise. So if we were going to our periodic table, we'd find that oxygen. I'm just going to draw what it looks like in the periodic table. We'd have 16 at the bottom, or 15.99. I rounded to 16, and then 8 over here. So first, I want to find the number of protons. Remember, that's the atomic number over here, 8. Number of electrons is also going to be 8 because it's a neutral atom. And number of neutrons is simply going to be 16 minus 8, which is 8. So I can draw my nucleus first. I'll make a little circle here for my nucleus. I'll put 8p plus for my protons and 8n naught, just like a 0 there, meaning neutral, 8 neutrons. And then I'll start placing my electrons. I have 8 electrons to place. So what I'm going to do is I'm going to draw another circle over here to represent my first shell. and I'm going to place my first 2 electrons. So typically what we do is we pair the first one, or place the first one like this, and then we go clockwise and place another one at the edge over here. And you could actually even place them farther away from each other. So what I'll do is I'll actually do that for this one here, because there's 2, and it's not a really big deal, but just to make it nice and neat here, 1 there, 1 here. Now, what I need you to get is that this shell is now full. We've placed 2 electrons. We have 8 total. There's 6 left to place. Now this shell is full, so I have to start another shell, and I can start placing my remaining electrons on here. So when you place electrons on the second shell and the third shell, you start off by placing the first electron at the top. So 1, then go clockwise, 2, 3, 4, and then start to pair them. 5, 6. This pairing is important because it does play into the next model of the atom you'll study, and it also helps when it comes to drawing bonding as well, since electrons like to pair up. So do make sure you pair them in that fashion. I'm going to draw a Lewis dot diagram as well, just to show you what that would look like. So if we analyze this Bohr-Rutherford diagram, you'll see there's 8 protons, 8 neutrons, 8 electrons, 2 on the first shell, 6 on the last. The number of valence electrons is 6. 1, 2, 3, 4, 5, 6. And so that means if I want to draw a Lewis dot diagram for this, I would simply put O, the symbol, and then 1, 2, 3, 4, 5, 6. That would be a Lewis dot diagram. And this, let's go see if this drawing actually makes sense. So we're just going to go take a look at our periodic table. Let's keep the drawing here. So oxygen is in group 16, which means it should have 6 valence electrons. It's also in period 2. So you'll notice that this is period 1 over here, and then period 2 is the second row, which means it should have 2 shells based on how we drew it. So overall, that makes sense. There's 2 shells, and there's 6 valence electrons. So based on the position, that looks like we're on the right track. And then here, you can't really tell how many shells you have, but we have our symbol oxygen, and then our 6 valence electrons for our Lewis dot structure. Now let's go ahead and do the same thing for sulfur. So sulfur, let's go take a look at sulfur in the periodic table. Sulfur is S over here, 32.07, so I'll round down to 32, and atomic mass, or atomic number of 16. So 32, sulfur, 16. So it would have protons, 16 from atomic number, electrons, 16 from atomic number, neutrons, 32 minus 16 gives you 16. So let's go ahead and draw the nucleus first. 16 protons, 16 neutrons. Let's make our first circle over here. 1, 2. That's full now. We've placed a 2, so that's full. Now we have to go and make another shell because we still have 14 electrons left to place. So 1, 2, 3, 4, 5, 6, 7, 8. This is now full. We've only placed 10 electrons, 2 on the first, 8 on the second. So we have 6 more to place, but the last shell here is full. So I'm going to be making a third shell and then just putting my last few electrons there. So 1, 2, 3, 4, 5, and 6. And so now I've placed all my electrons. So I have 16 protons, 16 neutrons, 16 electrons, 2 on the, and just counting here, 2 on the first shell, 8 on the second shell, and then 6 on the last. So that's 2 plus 8, that's 10 plus 6, 16 electrons placed. We can go and take a look to see if that makes sense based on the position of our sulfur on the periodic table. So sulfur is in group 16, like oxygen is, so it should have 6 valence electrons, which makes sense. But it's in group 3, it's in period 3. So third row, meaning that it has 3, it should have 3 shells. And so it does. It has 1, 2, 3 shells. Do not count the nucleus as a shell, so 3 shells there. And we can do a Lewis dot structure as well. So Lewis dot structure, we're going to replace every inner part there, those core electrons, let's call them for now, and the nucleus by the symbol, and just put the valence electrons. So there's 6 valence electrons. So 1, 2, 3, 4, 5, 6. This is a Lewis dot structure for the sulfur atom. So in this lesson, we saw how to draw Bohr-Rutherford diagrams for various elements, and we also added in the concept of Lewis dot diagrams, which only represents the valence electrons because valence electrons are the most important ones. And now you should understand this joke here. We have sodium, 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 Batman. If you haven't watched the old Batman, look it up and you'll understand it. Sodium is nah. Na 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 Batman. How do we know this is sodium? Just to verify, we didn't draw the nucleus in, but there'd be a nucleus there. 1 shell, 2 shells, 3 shells. So this is the third period, 1 valence electron. So first group, third period, and we can take a look if that's sodium. So we said first group, third period, and that's sodium.